Hey, this is the lecture video for MAC 1140, Pre-Calculus. We're in section 11.3, Systems of Linear Equations. Specifically, we're going to be looking at how to calculate determinants and the role that those determinants play in finding the solutions for a system. Okay, we're going to be taking a look at 2 by 2 determinants as well as 3 by 3 determinants. The 2 by 2s are used whenever we have a system that has two variables, x and y. And the 3 by 3s, which we'll see a little later, are for systems where we have three variables, x, y, and z. So as you see right here, referring back to this is a 2 by 2 determinant. These are the symbols that are most commonly used. And this is the formula for calculating the value that we call the determinant. What this formula is trying to show you, and I have a diagram here that's going to help you remember how to do the products. The important thing to remember is that whether you're doing the smaller 2 by 2 determinants or whether you're doing the 3 by 3 determinants, you always do the downward products first. So in this formula, as you can see, you're doing A times D first. That's the downward product. And then from that, you're subtracting the upward products. And that's how you calculate the value of a determinant. Okay, and this is just a little diagram to help you remember what I just did here. How this applies to a system. This is an example of a system where A, B, C, and D represent the coefficients. S and T are the constants on the other side of the equal sign, and the variables are x and y. So what you're going to see is that when we do start working with what's called Cramer's rule in order to find the solutions for this system, it's going to have to do with three different determinants. We will move this on to, a bigger system, three variables, but for right now, let's try it with two. So the first thing you're going to do is what's called the main determinant. That's composed of the coefficients that belong to the variables. So in this main determinant, there's A, B, C, and D. And as I stated up at the top, if you want to do the value of the determinant, because the values of these determinants is what we're going to use when we apply Cramer's rule to find the solutions. So again, it's the downward product minus the upward product. Then we're also going to be doing what we call the determinant in terms of x. And the way that you create that determinant is you take the first column that typically are the coefficients for the x's and you replace that column with the constants. So whatever these constants are on the other side of the equal sign, they will replace the x column to create the determinant that's called d sub x. To calculate the value of that determinant, you'll do exactly the way you've done all of the determinant values so far, the downward product minus the upward product. When you go to do what's called the d sub y determinant, then you're going to take the y column, the values that were in the y column, b and d. These came from the coefficients of the y variables, and you're going to take the values in that column, and this time you'll use the constants in that column. And that creates the determinant d sub y. Okay, so once again, when you're looking for the determinant d sub x, you will use these constants in place of the x column. When you're looking for the determinant called d sub y, you'll replace the y column with the constants s and t. Products are always done downward product first, a times t, minus the upward product, c times s. That's how you do the values of a 2 by 2 determinant. So what Cramer's rule says is that you can find the solutions for a system. In other words, you can find x and y in your system by using this formula. Okay, this is referred to as Cramer's rule. You use the d sub x value divided by the determinant value from the main determinant. The main determinant always plays the role of the denominator. Therefore, the value of the main determinant cannot be 0, otherwise these would be undefined. When you're looking for the solution for y, it's the value of the d sub y determinant divided by the value of the main determinant. Pretty easy. Okay, you just have to work with it a little bit to get used to it. It becomes pretty cumbersome when you are when you're doing it using 3x3 determinants. That's a lot of work. I mean, I don't know that this is the quickest way to find the solutions for a system. Obviously, the easiest way was from section 11.2 when we were using our calculator, entering the entire system and bringing it down to reduced row echelon form. But we do use this for other applications, and so I have to make sure that you understand how to use Cramer's rule for a 2x2 system and for a 2-variable system and also for a 3-variable system. So in this particular problem, I mean, you actually have the answer to this right up here because I gave you this same system as a way to define it. Right up here, and then you can see it again right here. So you actually already have the answer to example 1. Okay, the value of this determinant, you don't actually have numbers, but we will move to examples where we have numbers. It's just A times D. Always that downward product first. Make sure that you're always doing that. And then the second product will be the upward product. So get in that habit of going downward first. Okay, moving to example 2. These are all, first 3 or 4 examples will all have to do with 2x2 determinants. Okay, here we have another 2x2 determinant. These are the symbols we use for determinant. They kind of look like absolute value symbols. And again, knowing how to get the value of this, we do the downward product first. Oops, sorry, you can't see what I'm doing. And then do the upward product, which will be negative 35. Remember, it's downward product minus the upward product. So you'll have a double negative there. Okay, this ends up being 4 plus 39. So the value of that, 4 plus 35, so the value of that determinant is 39. Okay, then we move to this one. Still, you have a 2x2 determinant, 2 rows, 2 columns. This time you're going to use it to solve this little equation, but using the formula for the determinant. So going down, we have 6 times x. That's the downward product, and then it's always minus the upward product, which would be negative 4 times x. Okay, downward product minus upward product. Okay, this ends up being 6x plus 4x, which is equal to 10x. Now the determinant that I just calculated is said to be equal to 20, according to this problem. So the value of my determinant right here turned out to be 10x, and the value of this determinant is equal to 20, which gives me this equation. Okay, then I'm going to solve it by dividing both sides by 10, and I end up finding the value for x, which is what I was being asked to do, solve for x. Okay, here we're going to use Cramer's rule, which means we're going to have to do several determinants. They're not actually asking you to go all the way here, although we will in the next problem, in problem 5. Here they just want to see if you can carry out the formula for Cramer's rule. So what Cramer's rule says is that if you are trying to find x, you should have the d sub x determinant on the top, which in this case happens to be, okay, let's review how you get the d sub x determinant. The main determinant would be 2, 3, 1, negative 4. That's what you can see down here. But when you're doing the d sub x determinant, you take the x column and replace it with these constants. So 5, negative 3, and then the other column will be the same as it was in the main determinant. So you can just be looking at the main determinant and you're replacing this column with the constant. So 5, -3, and then copy the other column, which is 3, -4. And I don't believe they ask you to go any further than that in that particular question, just to set it up as though you were going to go all the way, as we will be doing in example 5. Okay, so once we get to example 5, now we're starting off with a system like we did in this problem, but we're going to go all the way. Okay, so there are 3 determinants involved here. The main determinant, which is just the values that represent these coefficients, 1, 1, and then 1, -1. So that's the value of the main determinant. And you can go ahead and calculate each one as you go along. Make this a little bit nicer. Okay, so if we're doing this determinant right now, 1, 1, and then 1, -1. I didn't put the negative there. Would be the downward product first. Don't forget to do that first. So it's -1 minus, and then do the upward product. 1 times 1 is 1. So this turns out to be, this combined with this is -2. So we have one of our determinant values. Next, we're going to do the determinant of x, because we are being asked to solve the system, which means we want to know what x as well as y is. So we need the d sub x determinant, which will just be this main determinant here, only the x column, which is this. This is the x column. This is the column of y's. This x column will be replaced with these constants. So 5 and 1. And then the rest of it will be the same. This column right here gets replaced with the 5 and the 1, and then you copy the other column as is, 1, -1. You can go ahead and do that value by doing always the downward product first, which is -5, minus whatever the upward product is. 1 times 1 is 1. That turns out to be -6. Next determinant that we need to do is the d sub y determinant. And that determinant, again, is just going to be the main determinant, but with the y column replaced by these constants. So 5 and 1, where the x column stays the same. Calculating the value for this d sub y determinant, it's downward product, 1 times 1 is 1, minus 1 times 5 is 5. And that turns out to be -4. Once you have a determinant for each of the variables as well as the main determinant, then you're ready to start finding the values, the solutions for x and y. So looking for x, the formula is the value of the d sub x determinant divided by the value of the main determinant. So our d sub x value was this, -6, and the value of the main determinant was this, -2. So the solution for x is 3 using Cramer's rule. Okay, then looking for the solution for y, that would be the value of the y determinant divided by the value of the main determinant. So the value of the y determinant turned out to be -4. Divided by the value of the main determinant, which is -2. So that ends up being 2. So in the end, our solution for x is 3, and our solution for y is 2, which you can also write as an ordered pair. Okay, now moving on to 3x3s. Now what you see here, these didn't come out too dark, but this is just a constant here, a constant here, and a constant here. Okay, so this is what we call a 3-variable system, as you've seen in previous section. There's an x variable, a y variable, and a z variable in each one of these equations, although one of the terms, could be missing. and each one has a coefficient. So you have all your coefficients for x in the first column, all your coefficients for y in the second column, all your coefficients for z in the third column, and then all your constants, just like you've had in the previous sections. And you can also use Cramer's rule like we just did in examples 1 through 5 and determinants in order to find the solutions for x, y, and z. So we're going to build up to that. First thing you need to be able to do is find the determinant of a 3 by 3. These determinants are all square. In other words, the dimensions are equal. If there's 3 rows, there's 3 columns. It has to be square. Okay, so as in when we were using Cramer's rule to find the values for x and y variables, just remember that the main determinant that plays the role of the denominator, it cannot be 0, and such is the case here, which is what this says down here. Okay, that's saying that the main determinant cannot be equal to 0, otherwise you cannot use it in Cramer's rule. But it's going to be the same thing, it's just the way that you calculate the determinant for a 3 by 3. Well, you can do it by cofactors, but I am going to be talking, you can do it by what's called expanding the minors, but it's too much work. So what we're going to do is I'm going to show you a shortcut for doing the determinant of a 3 by 3. Okay, moving to the next page where we actually start doing that. Here's just a little picture of what I'm going to be saying to you right now. Again, we're going to stick to the system where we do the downward products first. So what you're seeing right here is the main 3 by 3. 3 rows, 3 columns. But if you want to be able to use the shortcut that I'm going to teach you for calculating the determinant value of a 3 by 3, you have to expand this determinant. And you expand it simply by doing this, copying the first column as well as the second column on the outside of the determinant bars. Okay, so notice that this first column is right here, second column is right here. Then you can do 3 downward products. You're going to add all those products together. So you're going to do the product of these 3 numbers plus these 3 numbers plus these 3 numbers. All of that will be used to do your downward product value. Then from that, you're going to subtract the sum of all the upward products. So product plus product plus product, that'll be your downward product value. And then product plus product plus product, that'll be your upward product value. And you'll subtract this upward product, the sum of the upward products from the sum of the downward products. And that is written for you right out here. So basically it's showing you this. When you went downward on this string right here, you get a 126, negative 7 times negative 9 times 2. Plus you want to add this other downward product to it. So negative 10 times 2 times 7, that's negative 140. Then this last downward product is positive 12. So you're going to add together all of these downward products to just get one downward value. Then from that, you're going to subtract the sum of all the upward products. So 7 times negative 9 times 4 is this negative 252 that you see here. Then 1 times 2 times negative 7 is that negative 14 that you see. And then 2 times 3 times negative 10 is this negative 60 that you see. And you'll get one value here, which represents the upward product. Okay, so upward product being subtracted from the downward product, just like when you were doing the 2 by 2, but it involves more numbers. You can see there's 3 numbers for each one. Okay, let's actually give this a shot. Cramer's rule is spelled out for you here, that if you actually want to apply this to solving a 3-variable system, you would get x like this, the d sub x determinant, that's an x, I guess I did that kind of small, divided by the main determinant. Then you will do the d sub y determinant divided by the main determinant, and then you'll do the d sub z determinant divided by the main determinant. Okay, let's give that a shot now as we go to look at example 6, 7, and eventually we'll get to the point where we'll use Cramer's rule to solve a system. Okay, right now we're just practicing finding the determinant because we can't use Cramer's rule because Cramer's rule involves actually four determinants when you're doing a 3-variable system. So we have to get down how to get the determinant value. So let's just practice what I laid out for you right here. We'll just actually do it ourselves. First, we're going to expand, copying these first two columns on the outside of the determinant. Column for x's is 2, 1, 1. Column of y's is 4, -1, and 5. We're going to do our downward products first. First one, keep it straight, maybe draw that line right through them, is going to be equal to 2 times -1 is -2. -2 times 4 is -8. Go on to the next one, which would be this downward product. So 4 times 3 times 1 is +12. Next downward product would be -1 times 1 times 5. So that'd be -1 times 5 is -5. So all of this represents the downward product, which is 4. And then, of course, you can use your calculator. This plus this is 4. 4 take away 5 is -1. Okay, so now from that, we're going to subtract the sum of the upward products. And those upward products, this would be the first string of 3 successive values on a diagonal, because that's not 3, that's only 1. This is 2. Finally, you get to 3 of them. So 1 times -1 times -1 is 1. And then the next string of 3 values on the diagonal going upward would be 5 times 3 is 15, times 2 is +30. Just let that sign on the number evolve as you do the product. And then here we have 4 times 1 times 4, that's +16. These all put together is 47. So it's -1 minus 47. This turns out to be -48. And that is the value of the 3x3 determinant. Okay, moving to example 7. In example 7, we're looking at another 3x3 determinant, only this one of the entries is an x, and they want you to solve for x. So it's just going to be part of the equation as you use the formula for calculating a 3x3 determinant. Okay, don't forget, when you're doing a 3x3 determinant, we'll worry about setting it equal to 5 in a minute. Let's just get ourselves set up to calculate this determinant. I just have to copy it again because that -5 is in the way. Okay, so just take the first 2 columns and copy them on the outside of the bars. Try to copy them straight so that they line up on the diagonal. Okay, now we're going to do the downward products first. The first 3 that I can line up are these 3. Okay, so that's going to be 5 times x times 3 would be 15x. So this is my first downward product. Keep going, doing all the downward products. And then this is the next string of 3 numbers which we're going to product together. So 1 times -4 is -4, times -1 is +4. Okay, then we're going to do this last string of 3, forming the product. This would be -1 times 2, -2. From that, we're going to subtract the sum of the upward products. Okay, so this will be my first string of 3 that goes upward. So -1 times 5 is -5, times 1, -5. Doing this next upward product, it's 2 times -4 is -8. -8 times x, -8x. And then this last upward product is 3 times -1 is -3. -3 times 1, -3. Then you're going to keep going with this. Remember that it's equal to -5, but we might as well continue doing the value of the determinant. So in this first parenthesis, we have 15x, combining the 4 with the -2 is -2. Then in this parenthesis, we have -8x, and if we combine the front number and the back number, we have -8, but we are supposed to be subtracting that. Let me put this a little bit lower. So this was 15x. Let's see, what did I have there? But anyway, yeah, I think I had a +2. I don't know if I wrote it wrong or not, but it's 15x plus 2. So 15x plus 4 minus 2 is 15x plus 2. And then when you bring this down, it's opposite of -8x, which is positive 8x. And then opposite of -8 is positive 8. Keep going with that, and you end up with 23x. So 23x when you combine all the x's, and then 2 plus 8 is 10. Okay, so finally we have gone as far as we can with calculating the value of this determinant. So they're saying that this determinant, whatever the value happens to be, is equal to -5. So now we drag in that -5. We end up with an equation. This can be brought over here as -10. We have 23x is equal to -15. Divide by 23, divide by 23, and you have the value of x, -15 over 23. So these are just problems that when they make one of the entries in x, they gave you one like this when we were doing the 2x2 determinants, and now another one's been thrown to you when we're doing the 3x3. You're not solving a system, you're just having one of the entries where it's some kind of variable, and you're using just the formulas for finding a determinant. Here we were practicing how to calculate a 3x3 determinant value, but turning it into an equation. Okay, because of that. All right, moving to number 8. Not too many problems in this particular section, but I'm giving you one of each type of problem that you're going to see in your homework. Okay, so now we get to the longest problems, and that's when you're actually going all the way to using these determinants and Cramer's rule in order to find the values of x, y, and z. So you're going to need 4 different determinants. First, you're going to need the main determinant value. Then you're going to need the d sub x determinant, the d sub y, and the d sub z. Okay, so the first determinant would look like this: 1, 4, 1. Next row would be 1, -1, 3. Okay, then the next column would be -1, 1, -1. And then you have to expand that determinant. So once you get the main determinant, just the coefficients, because just the coefficients go into the determinant. However, if you're going to move on to use Cramer's rule, then you drag these constants that are on the right side of the equal sign. They replace at one point the x column, then the y column, then the z column. Now, as we're setting up these determinants, we might as well find the value. So remember, when you're finding the value of a three rows, 3 columns, you have to expand by copying the first 2 columns on the outside of the determinant symbol. So 141 would be copied out there, and then 1, negative 1, 3. Okay, calculating this, we're going to do all of the downward products first. So 1 times negative 1 times negative 1, that would be 1. Okay, then the next downward product would be these three that line up. Do the product there, 1 times 1 times 1. Turns out to be positive 1. Then this next string of numbers on the diagonal gives us the last downward product. So negative 4 times 3, negative 12. Then from that, we're going to subtract the sum of all the upward products. So this would be the first upward product. 1 times negative 1 times negative 1 is 1. Okay, then the next upward product would be 3 times 1 times 1, positive 3. Then the last upward product would be negative 1 times 4 times 1 is just negative 4. And that would be, let's see, 1 plus 1 is 2. 2 take away 12 is negative 10 minus, and then here you would have 4 take away 4. So that just turns out to be negative 10 for the value of the main determinant. And we'll use that later when we go to start solving for all the variables. Right now, we're just trying to find the values of all the determinants. Next, I'm going to do the determinant, the d sub x determinant, which means, and I'm going to keep looking at this main determinant because each time I go to do d sub x, d sub y, and d sub z, I'm going to be replacing one of the columns with these constants on the right side of the equations. Okay, so this time replacing the x column with these values, 7, 18. Just bear with me, this is a lot of work, this problem, but keep the rest of the main determinant the same. So 1, negative 1, 3, and then negative 1, 1, negative 1. Negative 1, 1, negative 1. Okay, now we're going to expand it, copying the first two columns on the outside of these bars. So do 7, 18, and 11, and then 1, negative 1, 3. Do the downward products first, so we're going to do that one. So 7 times negative 1 times negative 1 is 7. Then we're going to do this next downward product, which is positive 11. Then we're going to do this final downward product, which is negative 18 times 3, which is 54. Negative 54. Let me write a little clearer. Can't really tell what that is. That's an 11. And then this third one is the negative 54. And then from that, we're going to subtract all of the upward products. So here's the first upward product, and that's 11 times negative 1 times negative 1 is positive 11. And then the next upward product would be 3 times 1 times 7, positive 21. And then the last upward product would be negative 1 times 18 times 1, so negative 18. Okay, so putting all these numbers together, we have 18, take away 54, and that is negative 36 in this first parenthesis, minus, and then when we put all these together, 11 plus 21, take away 18 is 14. That came from this value, and then these two combined is negative 50. So now we have d sub x, and still have d sub y and d sub z to do. So d sub y is right here. This time we're going to be replacing the y column with these constants. Again, look at this main determinant because you're just replacing that middle column, which is the coefficients for y, with the 7, the 18, and 11. Everything else gets copied the same. So the 141 gets copied as is. Then the Y column gets replaced by the 7, 18, 11. Okay, and then that Z column gets copied as is, -1, 1, -1. Okay, to do the value of this determinant, we have to do it like this, expanding it by copying these first two columns in the determinant on the outside. So 1, 4, 1, then it's 7, 18, 11. Okay, doing the downward values first. So this is going to be -18. Next downward product is +7. And let's see. I feel like I copied something wrong here, so let me just check this real quick. So it was 1, 4, 1, 7, 18, 11, and then that last column was -1, 1, -1. Okay, so I did copy these right. All right, so this was -18. Okay, and then when I copy this, this is +7. And then when I do this last downward product, that's 1 times 4 times, -1 times 4 times 11, that's -44. And then from that, we're going to subtract all the upward products. So this is going to be 1 times 18 times -1, which is -18. Then this upward product is 11 times 1 is 11 times 1 times 1 is 11. And then this upward product is -1 times 4 times 7. And that's going to be -28. Okay, so there's a lot of work to do. Check my work as I go along. 1, 4, 1, 7, 18, and 11 is right there in the middle. And then that last column is -1, 1, -1. When we did this, it was -18. When we did this, it was +7. When we did -1 times 4 times 11, that was -44. Upward products, -18. Second upward product, 11. Third upward product, -28. Okay, now we're going to put these together. So -18 plus 7 minus 44 is -55 minus, and then -18 plus 11 minus 28. So this is -55 minus, and then when you put all these together, you get -35. So this is -55 plus 35. So this combined with this is -20. Okay, moving on to D sub Z. So easy to make a mistake here. All right, so now we're copying from the main determinant, column X, column Y, but replacing the Z column with 7, 18, and 11. So 1, 4, 1, and then 1, -1, 3, 1, -1, 3, and then that last column will be replaced by 7, 18, and 11. closer so they line up a little nicer. And then 11. Okay, then expand that determinant right outside here, 1, 4, 1, 1, -1, and 3, and then start doing the values of the determinants, or of the diagonal products. So this is going to be -1 times 11, -11. Then 1 times 18 times 1, that's going to be positive 18. Okay, and then 7 times 4 times 3, that's 7 times 4 is 28, times 3 is 84, and that's positive 84. Okay, from that, we're going to subtract the upward products. This first one would be -7. Then the next one going upward would be 3 times 18 is positive 54. And then the next upward product would be 44. Okay, this product right here would be, I'll just do it right here, -11 plus 18 plus 84 would be 91 minus, and then this would be -7 plus 54 plus 44, that would be 91, which is equal to 0. So now we finally have d sub y. Finally, to get the solutions, solution for x is the d sub x value over the value of the main determinant, which we've already calculated everything. So d sub x turned out to be -50. And the main determinant turned out to be -10, which is 5. So we have one final value for x. Okay, next is y. And when you're doing y, it's the d sub y determinant over the main determinant value. D sub y determinant ended up being -20. And the main determinant ended up being -10. So -20 divided by -10, 2. Now we have y. And then for z, it's going to be the d sub z determinant value divided by the main determinant value. So this would be, d sub z turned out to be 0. So regardless of what the determinant value is, it's going to be 0. So this is equal to 0. Okay, so we finally have all of our solutions for x, y, and z. Okay, x was 5, y value was 2, and the z value was 0. And you can give them, just write them separately, or you can write the solution as you write a solution for any 3 variable system. You can write it as a triple ordered pair. So 5, 2, 0. Okay, so moving on to example 9, where it says a triangle has vertices x sub 1, y sub 1, another vertex is x sub 2, y sub 2, and the third vertex is x sub 3, y sub 3. And then they give you a formula for the area of a triangle using the absolute value of a determinant. This is the determinant set up where these vertices of the triangle are the values inside the determinant, but then they tell you what those determinant coordinates are. So we can actually rewrite this determinant, calculate the value, then multiply it by 1/2. So putting in the values here, this is going to be 1/2. Our new determinant, once we put these values in, let's see, we're going to have all the x's going across the top. x sub 1, x sub 2, x sub 3. So 2, 6, 7, 2, 6, 7. Then going across row 2, we have all the y coordinates, y sub 2, y sub 1, y sub 2, and y sub 3. So that would be 4, 2, and 4. And then going across the bottom, we have all the ones that they've given us. We've already used all the coordinates that they've given us here. Okay, so if we want to be able to get the area of this triangle using this particular method, that means that we're going to have to know what the determinant value is. So I'm going to move that down here, 2, 6, 7. I'm going to expand it and calculate the value of this 3 by 3 determinant. Okay, so we're going to copy the first 2 columns on the outside of the determinant, 6, 2, 1. We're going to multiply the downward product, so this would be 2 times 2 is 4. Then the next downward product would be positive 24. Then the next downward product would be 28. Okay, then we're going to subtract all the upward products, which would be 2 times 7, 14, then 8. 1 times 4 times 2 is 8, positive 8. Then this last upward product would be 1 times 4 times 6 is 24. Okay, when we put all these together, that's 28 plus 28 is 56, and then we're subtracting 22 plus 24, which would be 46, which is equal to 10. So we at least have the value of the determinant, and I'll bring it up here and continue the problem. The actual area of the triangle is 1/2 by the absolute value of D. Okay, so this is going to be, area always has to be positive, so that's why they're telling you that if this determinant value does come out negative, that you should use the absolute value. So it's 1/2 times whatever the determinant value was, which is 10, and the area turns out to be 5. Okay, that completes the problems for section 11.3.